Okay, now this is the next unit, that is stress concentration. Topic is stress concentration. Okay, so let's see what is stress concentration. So first we are going to see what is stress concentration. It means what? Variation in properties of a material. Stress concentration can be happen with the help of anything. Stress concentration means what? At a some point more stress are acting. So why this thing happening? Why this thing happening? This has happened just because of some design effect, or because of some material, or due to some other thing, that we are going to see. So the causes of stress concentration, first we are going to see, just because of the variation in properties of material first, because it is assumed that the material is homogeneous throughout the component, but in practice there is a variation in material properties from end to another due to the following factors. First is the internal cracks and flows due to the blowholes, cavities in weld, air holes in steel components, non-metallic or foreign inclusion. Now these variation act as discontinuities, and these discontinuities causes the stress concentration at that point. Now the load applications, just because of the load application, machine components are subject to forces. So what type of force are acting at what time, it is not predictable. Okay, since sometime what happens, since the area is small, the pressure at this point is excessive. This can happen. The result is in stress concentration. Okay, now example of load application is contact between the meshing teeth of the gear of the driving and the driven gear. Okay, now this contact between the meshing teeth means it's having a very small contact, due to that a pressure is more. At that point stress will be more. Now the contact between the cam and the follower, then the contact between the balls and the races, contact between the rail and the wheel. Okay, contact between the crane hook and chain. In all these cases, the concentration load is applied over a very small area, resulting in stress concentration. So, I hope you understand that stress concentration is the part where a very small part is there, but at that point, or at that part, more stress is occurring, which can lead to failure. And the another problem is what? Causes of stress concentration is abrupt changes in the section. In order to mount a gear, sprocket, pulleys, and ball bearings on transmission shaft, steps are cut on the shaft and shoulders. Okay, so that we can easily feed that part. But this are provided from assembly and consideration also, just because of the assembly we did it. But all these features are essential and create changes in the cross section of the shaft. Okay, we know that these are essential things, but this create a cross change in cross section, and this result in stress concentration. Let's see. Now, discontinuities in the components. Certain features of machine components such as oil holes or groove and splines and screw threads result in discontinuity in the cross section. That means a full solid body is there and we are inserting a screw in that. We are inserting a slot in there. We are inserting a groove in that. That will becomes a discontinuity in the component. So this will give an cause of stress concentration at that region only, where the cross section is changed. Okay, so these are the points, that is the causes of stress concentration. Now methods of reducing this stress concentration, how we can, these we have seen the causes, now we are going to see the remedies for it. Now just see here, this is a variable cross section shaft. It's having a poor design because here a 90 angle is made. If a fillet is being inserted here, see here, the flow lines get changed. This blue line is showing me the flow lines. The flow line get changed, so it is a good one. If we are going to change this curve more, that means the round should be more, then it is a very preferred one, because it is going very smoothly. And if we are going to insert in this way. Okay, then it will be the preferred one. So both these things are the preferred value. So this is how we can change in the design, and we can avoid the stress concentration at one single point. Now this is for a cylindrical member with shoulder now. Same thing here. Okay, this is the preferred one. We can insert a hole at this region also, or at this region also, and this way. This is a poor design, and this is a good, and this is a preferred one. Now stress concentration for cylindrical member with holes. You can see here only one hole is there. Then what will happen? The curve is in this way. Okay, one dash type of this type of curve is created, mountain type shape. If two small hole is being created here, what will happen? The curve become a little bit a straight line. So this avoid the stress concentration at the single point. That means no stress concentration will be there at this hole. Now for the threaded zone. For threaded zone, you have seen that this is a poor design. This is a shank and a threaded part. It is started just after this. But if you're going to good design, so you need to give some space for this. And if the preferred one, that means the shank diameter should be throughout oh, same. That should not be changed in the cross section. Then there will not be any stress concentration in the threaded part. Okay. So whenever you're going to see such type of products, definitely its cost will be high. And for the poor design product, the cost is low. For press fit, you can see here how we are managing it. The curve part shown here. Okay. And if a slot is being inserted here, this will help it more. So this is how stress concentration is used. So I think you understand this part very easily. Thank you very much.